So today we will start the current electricity topic. At the beginning of current electricity, the concept that we have to know are the concept of drift velocity and motion of the electron through the conductor. Now, we all know that inside a conducting material, if we consider a conducting material like this, and you know that there are several electrons inside this conductor, many free electrons. Now, what do we mean by free electrons? Are they completely free and detachable from the conducting surface? No. They can freely roam between the conductor. Means the electrons these electrons free means they are not particularly bound to a particular atom. Okay. They can be free within the conductor. Within the conductor, from one atom to another atom, they can move freely, but they cannot be detached from the conducting surface. Okay. Now, so what will be the overall charge of the conductor? That is 0, because free electrons are not leaving the conductor such that the conductor will become positively charged. Conductor will be as a whole neutral, but these free electrons can roam inside the conductor from one atom to another atom without any barrier. Now, these electrons generally, when no potential difference is applied in the normal room temperature, they are moving randomly, completely haphazard motion, like this. Each corner point you can consider the movement of the electrons, and they are making a collision with the other electron, and then their path is changed. So electron is moving along this direction, then they suffer a collision here, then it moves along this direction, then it moves along this, in this way, completely. So this motion of the electron is called the random motion. Random motion. Now, what is the average displacement of a electron in this random motion? 0, because it is going here and there haphazardly completely. So on an average, you can consider if it moves in this direction by a certain amount, then in the opposite direction its displacement will be by an equal amount, such that the total displacement or average of the total displacement will become 0. As a result, average velocity is also 0. So average velocity for this random motion denoted like this. Average velocity of this random motion is 0. This type of in all cases of random motion, average velocity will become 0. Now, what is the average speed? Do you know what is the average speed of these electrons? Average speed is not 0, because average velocity becomes 0 since it is a vector quantity, because we can consider how much it moves in this direction, by an equal amount it moves in the opposite direction, so displacement 0, so the average velocity 0. But distance traveled, that is not 0, it's a scalar. So what is the average speed of this random motion? Very high. It is nearly, so average speed I will denote by this symbol. These two sign are representing that average value. This average speed of the electron without any vector, if you write, this is almost 2 into 10 to the power 6 meter per second. Nearly of the order of 2 into 10 to the power 6 meter per second. See, very high velocity. average speed of this random motion of the electron is nearly 2 into 10 to the power 6 meter per second. Now with this huge speed, still electrons are unable to produce current in the conductor. If there is a copper wire, is there any current flowing in this conductor? No, because due to this huge speed, since average velocity is 0, then current will not flow through the conductor. So for the flow of current, you have to ensure that the velocity of the electron, that is the average velocity of the electron, is not 0, and normally it will not happen due to this random motion. So we have to convert this random motion into a certain organized motion in a particular direction, then only average velocity will not be 0. Means random motion has to be converted into orderly motion of the electron. If there is a orderly motion in particular direction, we can say that average velocity is not 0, and that can only be done if an external field is used to move the electron in a particular direction, because otherwise electrons are charged particle. So charge particle will experience force when they are in an electric field. So you have to apply an electric field from externally such that the electron will feel force, and as a result electron starts move in a particular direction. Okay, so that's why battery is connected across this conductor, which will supply the electric field to the electron, which will apply force on the electron, and electrons are moving. And we can change the random motion into a organized motion such that we can calculate current and we can get current in the conductor. Okay. Otherwise, if you do not connect any battery, there will be so much electron inside the conductor, but still no current is no detectable current is formed, because due to average velocity of the random motion is 0. Clear? So write down, if the average velocity, since the average velocity of random motion, since the average velocity of the random motion of electron is 0 in a conductor, in normal condition, so no current is built in the conductor. So no current is built in the conductor. Okay. Now, how to calculate, how to apply the external field and such that the electrons are moving. Now, first we consider that we apply a certain field such that electrons are moving with a constant velocity inside the conductor in a particular direction. Electrons are moving with constant velocity in a particular direction. Okay. That particular constant velocity of all the electron in a particular direction is called the drift velocity. That is called the drift velocity. So let us consider that drift velocity of the electron is along this direction, and it is taken as Vd. Drift velocity of the electron along the particular direction is Vd. Once we use this cell, okay. So as we are using the cell is supplying a voltage, As a result, an electric field is applied on the electron, and electron will feel a force opposite to the direction of the electric field. Now see, electrons are negatively charged particle, these are, and this is the negative terminal of the cell. So electrons are feeling force, repulsive force from this negative terminal, so electrons are moving on this side. Okay, since the electric field produces the repulsive force on the electron, electrons are moving to that side. Okay, because negative terminal will repel the electron and positive terminal will attract the electron, so electron's motion will be along this direction. That's why drift velocity is shown along this direction. Now consider in a certain time t, in a certain amount of time, delta t I consider, small time, how much distance is travelled by a single electron? Its velocity is considered Vd. So Vd into delta t will be the distance travelled by the electron in a certain time delta t. So let us consider the electron is initially here. So this is not a single electron, this is a layer of electron, because there are too much, enormous number of electron in a conductor. So this layer contains certain number of electron, and electric field is applying a force on this layer. So entire layer is shifted from that position to this position in time delta t. So I can write this length will be Vd into delta t. This length will be Vd into delta t, means the distance covered by a layer of electron. Distance covered by a layer of electron is Vd into delta t, because electron is moving with a constant velocity Vd after applying the field, and in time delta t, then distance traveled will be simply speed into time, that is Vd into delta t. Clear? Now let us consider area of cross section of this conductor is capital A. Area of cross section of this conductor is considered as capital A. Then we are getting a small cylinder in the conducting material whose area is A and height is V delta t, Vd into delta t. So what is the volume of this small cylinder? A Vd into delta t. So I can write the volume of this small cylinder, this part is A Vd into delta t. Okay. So volume of the small cylinder which contains electron is A Vd delta t. Now let us consider that number of electrons per unit volume is small n. Write down, number of electrons per unit volume is considered to be small n. Then if I multiply this quantity with n, what I will get? Number of electrons, because number of electrons per unit volume is n, it is multiplied with that elementary volume. So we will get the number of electrons in that small volume. What is the charge of each electron? E. So I want to multiply this entire number of electron in this volume by the charge of an electron. So what we get? Total charge in that small volume, because Na Vd into t delta t will give you a number. number of electrons, suppose 1 lakh. So each electron having charge E, so 1 lakh electron having charge 1 lakh into E. Then this is the total charge contained in that small cylinder. So write down this one as delta Q. That is the amount of charge in this small cylindrical portion of the conductor. Now, delta Q by delta T, that will become N E A V D. Delta Q by delta T is then N E A V D. What is delta Q by delta T? Current. So this is the expression for the current, N E A V D. Okay. Now from this another formula we can find out, which will be required if some problem is coming, then we can use that formula also directly without deriving that, because I want to write another quantity, that is I by A. I by A, that can be written as NEVD. NEVD. This I by A means current flowing per unit area. Another term is there, current flowing per unit area of cross section perpendicularly. Current flowing per unit area of cross section perpendicularly means electron should cross this cross section perpendicularly, not obliquely. Then this quantity is called current density. Current density, that is current per unit area. It is generally denoted by this symbol J equal to NEVD. So you have to remember this formula also. J equal to NEVD. Because why this formula is famous? Because it is just one step from that I, formula for I by A. But still it is famous because here this one drift velocity I can write it as a vector, and J is current density is a vector. But remember, current is not a vector. Current is not a vector, so in that equation for current I cannot put the sign of direction of Vd. But in the calculation of J, since J is a vector quantity, I can put the direction of Vd. Okay. Now, I will ask you one question, that in which direction electrons are moving from the negative terminal of the battery to the positive terminal inside the conductor, and in which direction current should flow, positive to negative inside the conductor. Means current will flow in the opposite direction of the electron. Why it is considered that current is flowing opposite direction of electron? Who said? We consider that the electron, if electron is flowing, current is flowing in the opposite direction. But is it a convention, or is it truly a behavior of the material, or just a matter of convention? Someday someone can consider that electron and current both are flowing in the same direction, and positive charge is flowing in one direction, current is flowing opposite to the positive charge. Can the convention be changed? It's just a matter of convention, or it is a mathematical fact? See, in this case we are not putting any vector quantities, so that's why we are dealing only with the magnitude of the current. Current is not a vector, so that's why I skip all the signs and all the vector quantities. But J is a vector quantity, Vd is a vector quantity. Now, what is the sign of the charge of an electron? Minus. So it should be written, it can be written as, means the direction of J will be opposite to the direction of Vd. So if Vd moves along this direction, then J will be in the opposite direction, and J means current per unit area, so current should flow in the opposite direction of drift velocity of the electron. So that is directly calculated from the vector property of the drift velocity. Drift velocity of the electron in this direction, electron sign is already negative, charge containing negative charge, so there is a minus term in front of it. So if Vd is a vector along this direction, then minus of Vd is a vector in the opposite direction. So it shows that current will flow in the opposite direction of the electron, and it is not just a matter of convention, it is mathematically true. Okay. Now, but for most of the purposes we can drop this minus sign, and we can consider that it's a convention, then current and electron are flowing in the opposite direction. Negative charge and current are always flowing in the opposite direction. Now, normally speaking, we say that current is flowing from high potential to low potential, and electrons are flowing from low potential to high potential. This statement is completely wrong. If you say that current is flowing from high potential to low potential, this statement is wrong. You have to mention through which part of the circuit. If I consider this external circuit, this conductor, then current is flowing from high potential to low potential. But if I consider inside the cell, then current is flowing from low potential to high potential, because current is flowing in this way. So it is going from low to high. Clear? So in the external circuit and in the internal circuit, the direction will be different. In the external circuit, if current flows from high to low potential, in the internal circuit, means inside the cell, current is flowing from low potential to high potential. So whenever you are saying a statement that current is flowing from high to low, that does not mean anything. You have to mention where, inside the cell or in the external circuit. Otherwise this statement is meaningless. Okay, so write down current is flowing from high potential to low potential. Current is flowing from high potential to low potential in external circuit. In external circuit. But inside the cell, it is flowing from low potential to high potential. Low potential to high potential. Okay? Now I am asking you one question. The random motion of the electron for the current is converted to a organized motion such that we can calculate the drift velocity of the electron, and drift velocity is considered to be constant velocity with which all the electrons are moving. Now, how to create the drift velocity of the electron? By applying an external electric field. External electric field is supplied by the battery. Now, what external electric field will do? It will exert a force on the electron, because we know that force equal to Q into E. Q is the charge and electric field strength is E, then force equal to QE, and this force produces an acceleration. Then how drift velocity can be constant? If the force is there producing acceleration, then it must be accelerated motion, but you consider the drift velocity of the electron to be constant velocity. In presence of force, constant velocity cannot occur. In presence of force, only the accelerated motion can occur. Constant velocity cannot occur in case of the presence of force. Then how to consider that drift velocity is constant? Yes. Actually, what happens initially when the external force is applied by the field, the electrons are truly accelerating, but within a very small interval of time this acceleration comes to zero, because once the electrons are moved due to the field, then in front of it there are other electrons. So due to other electron it cannot go further. So as a result it will feel some repulsive force from the other electron also. So such that this applied force and this repulsive force from the other electron will balance each other. So net velocity force will become zero, and as a result the acceleration will become zero. So velocity suddenly increases from zero and becomes constant. That constant part is taken as the drift velocity. That constant part, it is just like a motion of a particle in a viscous medium, like raindrop. Initially it is increasing, but then goes on constant, achieving the terminal velocity. So same thing happens to the electron when we apply the field. Initially it is accelerating, reaching a certain velocity and become constant. Now you can say that after how long electron will reach this constant velocity? Within a very small time, within a few milliseconds almost, that even you cannot measure. You switch on the circuit and almost immediately electron achieve that constant velocity. Because do you know what is the magnitude of this drift velocity of the electron? What is the magnitude of the random motion's velocity? Speed of the random motion, that is 2 into 10 to the power 6. But drift velocity, what is this magnitude almost? Otherwise some student will come out from that door, then only this student can move a little bit. So that's why within a very small time electrons are reaching that constant velocity. That's why we can consider even in the presence of the field, the electron is moving with constant velocity. That is considered as drift velocity. Otherwise entire accelerated motion has to be calculated. Clear? So this is the concept behind the drift velocity. Now there is another equation that derivation is not required, but that is a very important equation, is this one. You have already studied this in your class 10 syllabus, that V equal to Ri. It is called Ohm's law. And in the 12th syllabus, there is this law also. This is also Ohm's law. First one is the Ohm's law in scalar form. Second one is the Ohm's law in vector form. In the vector form, it can be written as J equal to sigma E. J equal to sigma E. That is the vector form of Ohm's law. Now, you will find one formula for the sigma in your book, that is m by n square tau. M by n square tau. This one. M is the mass of the electron, n is the number of electron per unit volume, E is the charge of an electron. What is tau? Tau is called relaxation time. Means the time during which electron can relax. Means electrons are suffering collision with the other electrons. Between two successive collisions, the time spent by the electron is called the relaxation time. So that is called the average relaxation time, is tau. Now sigma is the called the conductivity of the material. Or the resistivity of the material, sigma. Reciprocal of resistivity. But now how this equation comes? By a direct substitution of the drift velocity in that I equal to NEA VD formula, you can find this one. So I will show that part, because otherwise you may forget what is conductivity and what is resistivity, and sometimes this conductivity and resistivity creates too much confusion, that which one is the n e square tau and which one is n square tau by m or m by n square tau. So that's why I will show you that calculation. See, this is the conductor. We connect the battery. This is the two layer. These are the two layers. I consider here it is V delta T, and already considered this one is A. So we have already derived this relation, that these are the some of the electrons we can consider. They are moving in this direction, and we have already derived this form I equal to NEA VD. I equal to NEA VD. Now, for a single electron, since the motion is accelerated, we consider, because electric field is applying some acceleration, then I can use this relation V equal to initial velocity Vi plus this equation is known to you, V equal to U plus AT. I have written. V is the final velocity, Vi is the U, that is initial velocity, and acceleration is E by m, because force on an electron is charge of an electron into electric field, that is E into E, capital E, divided by m means acceleration into t. So I have just using the equation V equal to U plus AT. Now I want to put vector sign on this. Fine. If I put vector sign, then this sign would be negative, because electron's charge will be negative. And this T I will change and write here tau. Instead of time, I consider tau, that is the relaxation time, because I want to calculate the velocity achieved by the electron after a collision and before the next collision. What will be the velocity achieved by the electron just before the next collision? Okay. Now, how many electrons are there? Many. Enormous number of electrons. So for single electron I cannot calculate. I have to calculate for all electrons. So I have to take the average, because some electrons can have a little bit higher velocity, some electron can have little bit lower velocity, some electron can have little bit more relaxation time, some electron can have little bit less acceleration time, but on an average these are same. So if I take the average of all these quantities, just this symbol is considering the average. Other things are constant. Then this is the average velocity of the random motion or organized motion. This one is final velocity. Final velocity means after applying electric field. After applying electric field, for the time of that relaxation equal to that relaxation time, the random motion is converted to the organized motion. Organized motion means this average velocity is now called the drift velocity, Vd. This one is initially. Initial means when there is no electric field. In that case, what is the random motion? That is completely random. So what is the average velocity? 0. So this one will be E by m into average relaxation time. Just simply average relaxation time, tau. So relaxation time is considered to be almost same for a particular material. Suppose aluminium, suppose iron, for a particular material relaxation time will remain same almost. This one. Now if I take only the magnitude, how we can write? This one will be E by m tau. This is the magnitude only, because direction we have already defined that if the electron moves in a particular direction, current will in the opposite direction. So I require only the magnitude now. Okay, so I will put this entire term over there. So this equation will become I equal to NEA, Vd means EE by m tau. Okay, EE by m into tau. Now let us consider length of this conductor is L and potential difference applied by the cell is capital V. Capital V. Don't confuse with this V, the velocity, because velocity I have written small v, and potential difference given by the battery is considered as capital V. Okay. Now, can I write this one? E equal to V by L. We have already written that negative derivative of potential is field. E equal to minus dV dr. So from that, without that minus sign for the sign, I can write potential difference by distance is equal to electric field. So here potential difference applied by the battery is V and the length of the conductor is L. So V by L will give you the magnitude of the electric field. Magnitude of the electric field. So here in this equation, now I will change that and write I equal to N square tau by M. This entire quantity is taken together into A into V by L. Capital E is replaced by V by L. N square tau by M into AV by L. Okay. Done? Now, from this, just write the expression for this V and you can identify many things. See, capital V can be written as M by N square tau. M by N square tau. L by A into I. See, capital V can be written as M by N square tau into L by A into now. Compare with the equation that you know, V equal to Ri. So this portion is resistance. V equal to Ri. So this portion in front of the coefficient of I is the resistance. So write it, R equal to M by N square tau into L by A. Now another equation that also directly comes, R equal to rho L by A, you know. Then rho is this portion. The bracketed portion is rho. That is resistivity of the conductor, M by N square tau. M by N square tau. That is the resistivity actually. So its inverse is conductivity. So conductivity will be N square tau by M. So that's why I said that once do this derivation when you are studying this portion, then after that you can remember the formula. Otherwise, haphazardly don't try to remember all the formulas, because there are so many formulas that even you can't remember everything. So once when you are preparing for the first time, just the derivation is there, just write it in a rough copy, then it will automatically be in your back of mind that this derivation is there. So formula remembering will be much more easier if you know the concept behind this and once do the derivation. But after multiple times when you revise, then automatically you can remember the formula. The detailed derivation is not at all required. Okay. So it clearly shows that formula rho L by A, that is coming directly from this calculation. So rho depends on which factors? Rho depends on m by n square tau, that is mass of the electron, charge of the electron, number density of the electron, n, and relaxation time. But among these, mass and charge of the electron are always same, because if the current is flowing through aluminum conductor or through iron conductor or through copper conductor, mass of the electron, charge of the electron will remain same in all the cases. Only the number of electrons per unit volume and the relaxation time will differ from material to material. That's why we consider that resistivity is a property of the material, because if you change the length or area of cross section, resistance will change, because resistance depends on these factors. But resistivity is this constant, so it does not depend on length and area of cross section. Okay, resistivity does not depend on length and area of cross section. It is a property of the material. It solely depends on tau and n only. Now, one question may come, that is also in your one of the mock papers, that is, show a graph between resistivity and temperature. The graph is there and you have to find out the correct graph. The temperature is changing, how the resistivity of the conductor is changing. So how to predict? Here there is no term containing temperature. So how can you say that resistivity is depending on temperature or not? That question is one of the mock paper. You have shown that question. That graph between resistivity and temperature is given, 3-4 graphs are given and you have to find the correct option. Then the resistivity formula that we derived, there is no explicit dependence on term temperature. Then how can you say that resistivity depends on temperature? What happens to the temperature? If you change the temperature, can mass of the electron change? No. Can electron's charge will change? No. Can the number density of the electron will change in a particular material if you change the temperature? No. But what about tau? Tau can change. Relaxation time means time gap between two successive collision of the electrons. If you increase the temperature, electrons' random motion will be too fast. According to kinetic theory, you know, electrons are moving here and there. So temperature means the average kinetic energy will increase. Kinetic energy increase means electrons are moving faster. So they have a higher chance of collision, means the relaxation time will decrease. Relaxation time decreases means rho will increase. So for a conductor, if you increase the temperature, resistivity will increase. As a result, temperature will also, resistance will also increase. So that is the cause. You increase the temperature, as a result random motion increases. Collision will be too frequent, so the relaxation time between two collision will decrease. Since tau decreases, rho will increase. Rho increases means resistance will automatically increase. So for conductor, if you increase temperature, resistance will increase. Temperature increases means resistance increases. Okay. So this is the explanation of this. So write down this one. If the temperature is increased, if the temperature is increased, the collision frequency of the electrons, will also increase. As a result, there is a decrease in relaxation time. There is a decrease in relaxation time. So the resistivity of the conductor will increase. Resistivity of the conductor will increase. And resistivity increases means resistance will also increase. Okay, is this portion clear? Okay, now so after this one you have to remember one more formula for this, that is very common formula. That is called the mobility. That is called mobility. It is defined as drift velocity per unit electric field. Drift velocity per unit electric field. That is called mobility. Now, this mobility defined by mu is analogous to the coefficient of friction. It is similar to that coefficient of friction. That is, through a material, through a conductor, suppose electrons are moving. So, conductor will offer some amount of resistance to the flow of this electron. That is measured by the factor mobility. Mobility high means it can pass easily. Mobility low means it will be slow down. Mane just opposite to the coefficient of friction. Coefficient of friction increases means the movement will be difficult. Coefficient of friction low means movement will be easier. Similarly, mobility is used in an opposite sense. If mobility is high, it can move very easily. If mobility low, the charged particle can move slowly. It will offer too much resistance will be offered to the charged particle to flow through the conductor. Now you know another type of moving charge, that is positive charge. In case of semiconductor, that is hole. Electron is carrying negative charge. In semiconductor, in conductor there is only electron, but in semiconductor there is another type of charge flowing, that is called a hole, which is positive charge. Generally, if we calculate the mobility of the electron is higher than the mobility of the hole. So in one topic is there in your syllabus of class 11-12, but now it is not in the syllabus, it is discarded. That is transistor, NPN transistor and PNP transistor. So most of the time NPN transistor is used, not the PNP transistor, because PNP transistor means 2 P side means hole is the majority carrier and N means electron. So two sides are hole, one side is electron. So in that case most of the carriers are hole. In that case mobility will be low and it will generate more heat. Otherwise, if you so most of the transistor used are NPN, such that two sides will be majority carrier electron, one side majority carrier will be hole. In that case number of electrons are more, that's why heat produced will be less. So this part, but it is not that much essential part, just you remember the formula. If something comes, then calculation of the drift velocity by electric field will give you the mobility directly. Okay. Now from after this I will discuss some problem regarding the resistance and resistivity and all these things. First problem, write down. A conducting wire is stretched. A conducting wire is stretched such that its length will be n times the previous length. N times the previous length or initial length. N times the initial length. Okay. Suppose initially L, now it is NL. What will be the resistance of this conductor? What will be the final resistance? What will be the final resistance of this conductor if initial resistance is capital R? If initial resistance is capital R. So you have to find the final resistance. What is the new resistivity? Suppose initial resistivity is rho. What is new resistivity? Same. V equal to V1 plus V2. Now I can write V1 means R1I, V2 means R2I. Then I can consider that I will replace R1 and R2 by a single resistance such that the current drawn from the battery will remain same. That single resistance is called the equivalent of this R1 and R2 connected in series. So that I consider as RS. So it can be written as I into RS. Then we can write RS will be equal to R1 plus R2. This is the series combination. Due to series combination, I use this symbol RS. Now, in case of parallel combination, there are two resistances connected like this. This is R1, this is R2. I consider I current is flowing. Then across both the resistance, potential difference is V. Same potential difference. But after coming to this junction, current is divided into two parts. I1 flowing there, I2 flowing there. Okay. Then we can write I will be equal to I1 plus I2. Previously, in case of series, I write V equal to V1 plus V2 because potential difference is equivalent to energy. That is conservation of energy. Now I am using who? I1 plus I equal to I1 plus I2. Now I equal to I1 plus I2 means conservation of current, that is actually conservation of charge. So for I1 I can write it is V by R1, for I2 it is V by R2. Then I consider instead of these two resistance, if I replace them by a single resistance Rp, which draws the same current from the battery, then that Rp is the parallel equivalent of these two. Then for that we can write V by Rp, and the equation becomes 1 by Rp equal to 1 by R1 plus 1 by R2. Okay. One by Rp equal to 1 by R1 plus 1 by R2. Now let us consider this situation. If R1 greater than R2, I consider this R1 greater than R2. What is the potential difference across R1? V. Potential difference across R2 is also V. So can I write I1 R1 equal to I2 R2? Both have the same potential difference connected across same potential difference. So I can write I1 R1 is potential difference for first one, I2 R2 is the potential difference for second one. So both are equal. Then from this I can write I1 by I2 equal to R2 by R1. Okay. So previous what we consider R1 is greater than R2. R1 is higher, R2 is lower. Then current through R1 will be low and current through R2 will be high, because these are inversely proportional. This is showing inversely proportional. I1 by I2 is equal to R2 by R1. So if R1 is more than R2, then current through R1 will be less than current through I2. So large current will flow through low resistance path and low current will flow through high resistance path. Okay, in parallel combination. But there is no such thing in series combination. Same current must pass through each and every resistor. Once two resistors are connected in parallel, then potential difference across them is same. then large amount of current will flow through low resistance path and small amount of current will flow through high resistance path, such that the product of current and resistance will remain constant in parallel combination. Clear? But in case of series combination, that is not true, because the resistances are not connected across same potential. So obviously same current, since there is a single path, so same current must pass through high resistance and low resistance both in series combination. Okay, because series combination you cannot say if R1 is higher than R2, then current through R1 is lower than current through R2. Both same current will pass, because there is only one path for the current to flow. Okay. Now, on the basis of this, we will discuss certain problems. This problem, that two problems that I have given in the last class for capacitor is equally applicable for resistance here. Same thing, same argument you can apply. That problem of the circle and connected in parallel, same instead of capacitor we can give resistance. Now, we will discuss some other problem. Clear this portion? Okay. Now, in this circuit, one unknown resistance is present, that is X, and it is claimed that the equivalent resistance between A and B is also equal to the value of that unknown resistance X. Other two resistors are given, 2 ohm and 1 ohm. Then what will be the value of X? Means find out the value of the unknown resistance such that the equivalent resistance is equal to the value of that unknown resistance. A quadratic equation will come, and from that you have to apply Sridhar Acharya's formula to solve, or you can do the other methods also. See how to solve this one. First consider these two. How they are connected? They are connected in series or they are connected in parallel? Parallel. Why parallel? They are placed parallelly? No. Because this point and this point are common point. Means potential difference between these 2 points is something, and these two resistance are connected between same potential difference. So they are in parallel. Clear? Now, so 2x and this one parallel. So what is their equivalent resistance? R1 R2 by R1 plus R2. So that is 1 into x, that is x by x plus 1, x into 1 by x plus 1. That is the parallel equivalent of these two. Okay. Now the circuit reduced. How? So this is 2, this is x by x plus 1, and this is x again. Now how these two are connected? Series. So their equivalent will be 2 plus x by x plus 1, and entire equivalent is predicted to be x. So now the equation is built. Now you have to solve. I can write this one as x minus 2 equal to x by x plus 1. So just cross multiply x into x, that is x square, minus 2x plus x minus 2. Okay, I cross multiply both the terms, x minus 2 into x plus 1. Then it will be x square minus 2x plus x minus 2, and that is equal to another x, this x. Okay, so this x and this x can be cancelled. Then without using Sridharacharya I can also solve. X square, right, minus 2x plus 1 plus 1. See, instead of minus 2 I write plus 1 minus 3. Plus 1 minus 3 is also minus 2. But now the first three terms will become x minus 1 whole square, that is equal to 3. So x minus 1 equal to plus minus root 3. Now you can write x equal to 1 plus minus root 3. Now don't write ohm directly. So what is your answer? Answer will be x equal to 1 plus root 3 ohm. This one, not the minus one. Why? Because resistance cannot be negative. Because root 3 is 1.732 greater than 1. So if you calculate 1 minus root 3, it will become negative. So negative resistance is not possible. So the positive value only you have to consider, that is 1 plus root 3 ohm. That is the value. From which part? Oh. See, these two are connected in parallel because these 2 points are common. So same potential will be there. So their equivalent will be 1 by Rp equal to 1 by R1 plus 1 by R2. From that, what is the value of Rp we know? R1 R2 by R1 plus R2. So here one resistance is X, another resistance is 1. So X into 1 by X plus 1. So X into 1 will become X. So this is the equivalent of these two. Now I replace this one, this 2 by a single. Then there is another 2 ohm. So if you connect a battery between these two, current will flow like this. So how these two resistances are now connected? In series, because same current will flow through them now. So that is connected in series. So their equivalent will be just the addition. So it will be 2 plus x by x plus 1, and total equivalent is given x. So I write the total equivalent as x. Equivalent resistance means sum of all this. So these two are now the resistance, they are connected in series, and their equivalent is given x. So I write it x. So from that I get this equation by multiplying x plus 1 with x minus 2. You will get x square minus 2x plus x minus 2, and there is only one x. So this 2x will cancel. So x square minus 2x minus 2. Either you can apply Sridhar-Acharya's formula from directly here, or without using Sridhar-Acharya's method, I write minus 2x plus 1 minus 3. That is 0. So x square minus 2x plus 1 will become x minus 1 whole square. This will become 3. So x minus 1 equal to plus minus root 3. So x equal to 1 plus minus root 3. Now if you take the minus sign, 1 minus root 3, this will be a negative number, because root 3 means greater than 1. So 1 plus root 3 is the correct option. There is something wrong, I think. Give me one pen. This one. From this one you have to use Sridhar-Acharya's formula. So A equal to 1, B equal to minus 2, C equal to minus 2. Just use minus B. B square. Why B square? X equal to minus B plus minus root over of B square minus 4AC by 2A. So use the wrong formula. Yeah. So that's why. So check. Minus 2. Minus of minus 2 will be plus 2. Plus minus root over of B square is 4 minus 4AC. 4 is there, A is 1, C is minus 2. So it will become plus. So 4 into 1 into 2 by 2A is 2. So it is coming 12. 12 means 2 root 3. So 2 plus minus 2 root 3 by 2. So 1 plus minus. Okay. What is the equivalent resistance between A and B? What is the equivalent resistance between A and B? Circuit? I can connect battery like this. Battery is connected like this. Now, what is the equivalent resistance? Seven. Correct. Seven. 8. Okay, take a small break, and during the break try to solve this question. Very difficult circuit, try to solve this one. Okay, see, this question's answer is 0. Equivalent resistance between this terminal A and B is 0 because presence of this line, it is a short circuited because that line is a zero resistance path, and if there is a zero resistance path, then entire current will flow through that path, and it is called the short circuit. In that case, the current will not flow through either of these paths. No current flow. Entire current will flow through this path and go to the battery. So all the resistance in this circuit are inactive. The total equivalent resistance is 0 because of the presence of short circuit path. Clear? Now, now we will discuss some of the cases of another resistance calculation. between A and D two diagonally opposite points, what will be the resistance? If all resistance are given small r, each resistance is small r, then what will be the equivalent resistance between A and D? A and D are two diagonally opposite points. See, don't try to find series and parallel directly from this, because you will be in difficulty. There are so many branches, so many things that is happening. So for solving this type of problem, there is a systematic method, and if you follow the systematic method, you can find the answer very easily. See how. Let us consider that current is flowing through the circuit through A. Think of it that a battery is connected here. Like this, between A and D. Now let us consider battery sends a current I in the circuit. Then after coming to point A, this current is divided into how many parts? 3 parts. Each part will be equal because entire part is symmetric. About this diagonal, if you consider a diagonal line, with respect to diagonal line, both sides of the cube are completely symmetric. Okay, so that's why current is divided into equal 3 parts. That means current flowing through this part is I by 3. This one is also I by 3. This one is also I by 3. Okay, I by 3, I by 3, I by 3. Then, if this part has a potential difference VA and I consider this point has potential difference VB, because current is going through a potential difference, then VA is of course greater than VB. Current is going from high potential to low potential. Clear? Now, if this is VB, I can write this one is also VB, because the same current is flowing through same resistance. Then this one is also VB. Okay, so what I did, I write the potential VA here. Same 3 currents are flowing through same resistances, so immediately after that the corner point has the same potential VB. This point is VB, this point should be VB. Now I use another. How much current is coming out through this point? Because the current that starts from the cell, is I. So how much current after all circuit will come back to the cell? Same current. Then I can consider that this I is composed of 3 currents, I by 3, I by 3, I by 3. Because here it is separated into 3 parts. Now all these 3 parts will join together to form I at point D. At point A, I is divided into 3 parts. So at point D, all these 3 parts should join to form I. Then accordingly, I will write that suppose this potential is Vc. So Vc minus Vd is a potential difference. Due to that, I by 3 current will flow. Vc to this one, I by 3 current will flow. Then if this is Vc, according to the same technique, I can write this is also Vc, this is also Vc. So I just distribute the potential at different points. So at point A, potential is Va, Now current is divided into 3 parts from point A and going to potential VB. So 3 points should be in VB. Similarly, at point D, all the 3 parts will join to form I. So they should come from the same potential. So I distribute the potential as VC, VC, VC. Now, nothing is required. I will write this circuit as like this. This is VA, this is VB, this is VC, this is VD. Battery is connected between which 2 points? A and D. Connect battery. Point A and D. How many resistances are connected between potential VA minus VB? 3. VA minus VB, VA minus VB, VA minus VB. So how many? 3. So these 3 are connected in parallel. Okay. How many resistance are connected between VC minus VD? VC minus VD. VC minus VD. VD is this one. VC minus VD. VC minus VD. How many? 3. So draw them. Then how many resistances are connected between VB minus VC? 6. Remaining 6. A cube has how many sides? 12. So 3 plus 3, 6 is already taken. So how many left? Another 6. So those 6 are connected between VB minus VC. So between VB minus VC, connect 6. Now calculate. So all are equal, small r. So their equivalent will be r by 3. Their equivalent will be r by 6. Their equivalent will be r by 3. All are connected in series. So ultimate equivalent will be r by 3 plus r by 6 plus r by 3. 2r plus r plus 2r. 5r by 6. That's the answer. So for this type of problem, no need to do some large calculation by using Kirchhoff law or anything. Just identify the potential, distribute the potential accordingly from the symmetry, and you can find the answer easily. Only carefully you have to apply the potential at different points. If you miss the potential, then you cannot solve. This current electricity part is very technical because it is actually a topic of the engineering part, because current electricity is part of the electrical technology. So that's why this is actually based on the technical part. So if you technically divide the circuit into parts, calculate the potential at the different points or explore the symmetry, you can solve the circuit without too much calculation. Okay. Just once go through the details. I will say one more time. That is, I connect the battery between 2 points. High potential is connected at A, low potential connected at D. So VA should be the highest and VD should be the lowest. Then from VA, the current is symmetrically divided into 3 parts, I by 3, I by 3, I by 3. So after crossing each R, I distribute the potential as VB, VB, VB. All 3 should have the same potential. Then at point D, the same 3 parts will meet to form the total current I. So each part should be I by 3. So the point from which they are going, I distribute the potential there VC, VC, VC. Then among the potential difference VA minus VB, I got 3 resistors. So between VA minus VB, I put 3 resistors, and all such are 3 are in parallel because they are connected between same potential drop. Similarly, between VC minus VD, 3 resistors are connected, so they are also in parallel. Then between the potential drop VB minus VC, remaining 6 should be connected, and since their potential difference same, so they are again connected in parallel. So parallel 3 resistors, then 6 resistors in parallel, then 3 resistors in parallel again, and total equivalent is the sum of all these 3 because these 3 are connected in series. That is the answer. Done? Now, how many of you know how to write Kirchhoff's law? Because that is a part that I have to explain completely, because you cannot remember the formula of Kirchhoff's law like this, because you have to apply Kirchhoff's law in the circuit to solve the problems. So how many of you know Kirchhoff's law, how to apply it? No one? Okay. See what Kirchhoff's law says. First write down, because though the law writing the law definitions are not required, but for understanding of the Kirchhoff's law you require this. First write Kirchhoff's current law. Algebraic sum of the current, algebraic sum of the current at any junction point in a circuit, algebraic sum of the current at any junction point in a circuit is 0. Point in a circuit is 0. Okay. Next, Kirchhoff's voltage law. Algebraic sum of potential drop or voltage drop, anything you can write, in a closed loop. Algebraic sum of the voltage drop or potential drop in a closed loop is 0. Okay. Now, first I will apply Kirchhoff's law to a circuit which is very simple. Even without applying Kirchhoff's law, we can solve that circuit. Then we will apply Kirchhoff's law to the complicated circuits. See, I consider first one, what the law says actually. Algebraic sum of the current is 0 first. 15 volt. Now, first consider that from this 15 volt some current will be sent in the circuit. That current is this one, considered as I. Okay. Then after coming to this point, this I is divided into two parts. One is suppose I1, another is I2. One is suppose I1, another is I2. It is divided into two parts. Now, in the Kirchhoff's current law, it is mentioned algebraic sum. How to take this algebraic sum? Incoming currents is considered as negative and outgoing currents from a point is considered as positive. So at this point, what is incoming current? I. So I is denoted as negative. So I write minus I. Outgoing currents are I1 and I2, plus I1 plus I2. That is called the algebraic sum. That is 0. Okay. But see, from this we can easily write this one. That is incoming current equal to outgoing current. Sum of the incoming current equal to sum of the outgoing current. Means the total charge that comes to a point equal to the total charge that leaves the point, means conservation of charge. So Kirchhoff current law is just the conservation of charge. It is not a new law. Current means flow of charge per unit time. So whatever be the charge comes to a particular junction, it will not accumulate it at that junction. The same charge will flow from that junction in various parts. It may be in parts, but the sum remain same. That is the main essence of the Kirchhoff's current law. So write down Kirchhoff's current law, where you write that it is based on conservation of charge. Okay, conservation of charge. Then, in this type of problem, what are actually asked? Find the current through every resistor. Find the current through every resistor. Then, through the first 3 ohm resistor, current is I. Through the other 3 ohm resistor, current is I1, and through the 6 ohm resistor, current is I2. So how many variable I have to find out? 3 variable, I, I1, I2. So how many equations we need? 3. Okay. Now see, one is Kirchhoff's current law, that is giving us one equation, I equal to I1 plus I2. The next equation comes from 2 loops, because there are 2 loops in the circuit. First loop, second loop. For 2 loops, I can apply Kirchhoff's voltage law for each loop and write one equation. So 3 equations can be built and we can solve this 3 equations. But wait a minute. In principle, number of equations and number of variable, if matches, I can solve the equation to find the variables. That is true. Now suppose if I have 7 simultaneous linear equation and of 7 unknown variables, and if I give it to you, how many time we will take to solve? It is 2 variable, okay fine. If it is 3 variable, you have to take too many times. Suppose there are 7 equations, 7 unknown. So Though in principle it is possible that number of equations and number of variable, if matches, we can solve it, but in practice if the number of unknowns are increasing, then even if I have the number of same number of equations, it is difficult job, because too many calculations are involved. So here I will not write 3 equations and 3 unknowns to solve. I will write only 2 equation and 2 unknown. Okay, but now you will say you have the 3 resistors, you have to find the current through each resistor, and you are saying that I will stick to the 2 unknowns. How is that possible? It is possible because I will apply Kirchhoff's law not as an equation, directly in the circuit to write the currents. I will apply Kirchhoff's law directly. I will not increase the number of equations. Okay, see how. Done. I will write I minus I1 directly. See, add these 2, you will get I. So write Kirchhoff's law directly at the junctions. It will reduce the number of variables, because if you write the equation in the equation form, then you have to solve for that, and during the calculation you may have mistakes. So to reduce the mistakes, chance of possibility of the mistake, write Kirchhoff's law directly. Hey, why are you become horizontal? Vertical. See, so write Kirchhoff's law directly at the junction. Okay, so if you write Kirchhoff's law directly in choosing reduced, such that number of equation will be minimum and you can solve it easily. Clear? Now, okay. See, now we apply Kirchhoff's voltage law. But before applying voltage law, I have to tell you something. Current is flowing from high potential to low potential through the resistance, means external circuit. Through the battery, current is flowing from low potential to high potential. Through the battery, current is flowing from low potential to high potential. Okay. Now, how to calculate potential difference? Remember, it is always defined as final potential minus initial potential, not that high potential minus low potential. In case of Kirchhoff's law, when you write potential drop, always remember potential drop is final potential minus initial potential, not the high potential minus low potential. If you remember this thing, you can apply Kirchhoff voltage law without any problem. And now, see, first I have to make a closed loop. What do we mean by closed loop? I will use certain points. Suppose A, B, C, D. If you are considering A, B, C, D, This loop is closed. If you are going from A to B, then from B to C, then from C to D, loop is closed? No. Now it is closed. A to B, B to C, C to D, D to A. Then it is closed. Now consider you are moving in this closed loop. Loop 1 I consider. In anti-clockwise sense, you are moving, completely imaginary. You are an observer. Current is not moving in this way, you cannot say. You are moving. You means an imaginary observer who is covering this loop in this manner, anti-clock. Clear? Now, what you find, you will write it as potential drop. What you find, what the actual potential drop, I will not bother. What you find as an imaginary observer in moving the loop in this sense, you will write that. First, start from this point. You are moving in this direction. So first you are getting which terminal of the battery? High potential terminal. Then you are getting low potential terminal. So voltage of the battery is written as minus 15 volt, because final potential is the low potential, initial is high. So final minus initial. So you write minus, so I write here for this first loop minus 15. Done. Then come to this point. There is no resistance or no battery, so nothing to write. Then C to D. First, current is flowing from through the resistance, it is flowing from high potential to low potential. Means this point is at high potential, this point is at low potential, and you are going from low potential to high potential. So final value is high, initial value is low. So what is that potential drop? Positive. Plus 3 into I1. Current is flowing from high to low. You are going from low to high. So you will encounter high finally. So final minus initial, that is high minus low, that is positive. Okay. Now for this one, again the same thing, current is going from high to low. You are going in the opposite direction, so you will encounter high finally. So final minus initial, that will be plus 3I, that is equal to 0. Loop complete. This is the algebraic sum of the potential drop across any closed loop. For the first closed loop, I write the equations. Okay. Now, I can divide the entire equation by 3 and write, simplifying it, I plus I1, that is equal to 5. Equation 1. Dividing entire equation by 3, then we can write I plus I1 equal to 5. Okay. Now we consider this second loop. Loop 2. In a similar manner, D, C, E, F suppose. So closed loop means I will start from here, D, C, E, F, D. D, C, E, F, D. Loop 2 is closed. Okay. The same manner, right? Current is going from high potential to low potential, and you are going from high to low. So what is potential difference? Minus, because you encountered the low potential later. So final value minus initial value. So that is negative 3 into I1. Then there is no resistance, nothing to write. Then finally comes to this point. High potential to low potential. You are going from low to high. So the difference is high minus low. That is positive. Equal to 0. Loop complete, because you go back to D, starting from D, loop complete. Now see what this equation gives you. You can write this one in this manner: 3I1 equal to 6 into I minus I1. You can also write this equation like 3I1 equal to 6 into I minus I1. What it basically gives? Two resistors are connected in parallel. See, this point and these 2 points, since there are no resistance are common, so these 2 resistors are connected in parallel. Parallel means same potential difference. See, the same thing comes. Potential difference means resistance into current. So through 3 into I1 is the potential difference, and through that 6 into I minus I1 is the potential difference, and both of them are equal. Both of them are equal means same potential difference across these two. Same potential difference means they are connected in parallel. So that we can find from the elementary circuit also. That is coming from Kirchhoff's law. Now divide both sides by 3. I can write here I1 equal to 2I minus 2I1. Then I can write 3I1 equal to 2I. So I1 will be equal to 2I by 3. This is my equation 2. Solve 1 and 2. Solve to find I and I1. Substitute the value of I1 in equation 1, and then you find I, and then putting it into 2 you can find I1 also. Check, I is coming 3 ampere. I is coming 3 ampere and I1 is coming 2 ampere. Okay. Then I can claim that through this resistance current is flowing 3 ampere. Through this one current is flowing 2 ampere. And through this one then current is flowing 1 ampere. I minus I1, that is 1 ampere. Okay. So this is the technique to write Kirchhoff's law. Kirchhoff's current law is very easy to write. It is only the incoming current equal to outgoing current. But there are difficulties in writing the voltage law. If someone remember this in this manner, that if you are going opposite to current, then it is positive. You are going according to along the direction of current, then it is negative. Don't go into that messy things. Just consider the potential differences, and according to your movement, whatever be the final potential, that final value minus initial value. If final value is low, initial value is high, so difference will be negative. Final value high, initial value low, difference will be positive. Just stick to this principle. You can write Kirchhoff's law for a voltage law for any loop absolutely correctly. There will be no difficulty in writing the Kirchhoff's law. But if you consider that according to the current direction, if I go, it is negative, then it is positive. Don't go on to that, all these logics. Clear? Now, so what basically voltage law says? Current law is conservation of energy charge. Voltage law, it is basically conservation of energy. You can think of it like this. This one is the supply voltage, that is source, and it is creating voltage across these two resistance connected in this loop. So total energy is divided into two parts. So when you add those two parts, it will be the total energy in that loop. That is basically conservation of energy. Similarly, this member is a common member of both the loops, because this one 6 ohm is not a part of the first loop. Now the common member is that 3 ohm. This 3 ohm will deliver the potential difference or energy to the 6 ohm. And how it is transferring? They are connected in parallel. So the same voltage is transferred by this member to that. So again the conservation of energy comes. Okay, so Kirchhoff's voltage law is just the conservation of energy equation for each and every loop. So current law, conservation of charge; voltage law, conservation of energy. That is the Kirchhoff's law, nothing else. Okay. Now, using Kirchhoff's law, you can solve many problems, and one type of problem is there which you cannot find. You can of course find using Kirchhoff's law, but that is very difficult to find because so many equations will come. One is the very common circuit that we can find from the Kirchhoff's law. That is the Wheatstone bridge circuit. R1, R2, R1, R2, this one is R3, this one is R4, and this one is a bridge line, R5, and I connect a battery, suppose here. Now in this case, if you are asked to calculate the equivalent resistance, then the problem is in solving the equivalent resistance, you cannot apply any elementary technique to find the small parts in parallel or in series, because you cannot consider R1 and R2 in parallel, or even R3 and R4 in parallel, because the bridge line is present. If the bridge line is removed, then you can solve the problem very easily. So there are many conditions in which there is certain condition in which we can remove this bridge line. That is, if R1 by R2 ratio is equal to R3 by R4 ratio, then you can remove this bridge line. Means if you have potential here VA, potential at this point VB, potential at this point VC, and potential at this point VD. So when this ratio is true, then this ratio will come, then VC will be equal to VD. If R1 by R2 equal to R3 by R4, then VC by VD, VC and VD will be equal. Then what is the potential difference? VC minus VD? Nothing, 0. VC minus VD will be 0 in that case. 0 means across R5 potential drop 0, means through R5 no current will flow. In that case I can draw the circuit like this. R1, R2 in parallel, R3, R4 in parallel, and both parallels are connected in series. Okay, so R1, R2 parallel, R1, R2's parallel will be R1, R2 by R1 plus R2. Similarly, R3, R4 in parallel, so R3, R4 by R3 plus R4. And they are connected in series means addition. So this is the equivalent resistance provided this condition is fulfilled. R1 by R2 equal to R3 by R4. What will happen if this condition is not fulfilled? If this is called the balanced condition of the Wheatstone bridge, when the ratios are in the two arms are equal. In that case, you can remove the bridge arm and solve the problem, and it is just a simple problem. But if the resistances and ratios are not same, then if you try to apply Kirchhoff's law, this relation can be derived from Kirchhoff's law. Derivation is already in your book. But if there are ratios are not same, then don't try to use Kirchhoff's law to solve the problem, because it will take too much, it will lead you to too much equations such that the problem solving will be difficult. I will show you one technique, that is, I will show you mechanically. I will not derive the entire formula and all these things, because that is not required. You can remember this formula and apply in any circuit, if this type of situation occurs. In Wheatstone bridge type of situation occurs, you can apply directly, whether it is in parallel, whether it is in not parallel, whether it is in reciprocal ratio, and all these cases it is applicable. See, just you have to remember those formulas properly. I will take one problem and illustrate this. First I will take a problem which can be solved by Kirchhoff's law. Can be solved by Kirchhoff's law. Not that much easily, but still can be solved. The problem is this one. Find the equivalent resistance between A and B. Find the equivalent resistance between A and B. First see, you cannot easily simplify the circuit. Why? Because elementary, suppose some part is parallel, some part is series, that is not in the circuit. Next, can we apply the situation of the balanced condition of the Wheatstone bridge? No, because the ratio of the resistances R1 by R2 is 1:2, but R3 by R4 is given reciprocal of that, 2:1. So it is not in the balanced condition. So through R4 definitely current will, through bridge line, that is R5, definitely current will flow. So you cannot remove this bridge line and simplify the problem. Then other option remains. One is Kirchhoff's law. But for the Kirchhoff's law I required a battery and etc. Nothing is given in the circuit. I will use a battery. See, consider a battery here. Potential difference V. Now, battery will send some current in the circuit, right? I. Okay. Now, after coming to this point, this current will divide into parts. I1 is going there, and since I mentioned that I will apply Kirchhoff law directly in the circuit, I will write this one as I minus I1. I minus I1. Okay. Now, this is 2 ohm. That is this is 1, 2. This is just inverted. So current will be inverted. So through this 2 ohm, if I minus I1 flows, then through that 2 ohm, I minus I1 should flow. And through this 1 ohm, if I1 flows, through this 1 ohm, just I minus I1 will, just I1 will flow. Such that the sum will remain same. Sum I have to remain same, because that is from the conservation of charge. I cannot alter the sum. Okay. Then come to this point. Which one is more, I1 or I minus I1? I1 is more, because that is passing through 1 ohm, and I minus I1 is passing through 2 ohm. So through large resistance, small current will go. Now, from this point, what is the incoming current? I1. What is the outgoing current? One part, I minus I1. So the remaining current will flow through this. So what will be the remaining current? Incoming current minus outgoing current. So that is flowing like this. So what is that? I1 minus of I minus I1. So what is it? 2I1 minus I. So write this current as 2I1 minus I. That is coming down through the bridge line. Now check whether current law is maintained or not. Add these two. This will become I1. that is outgoing current equal to incoming current, that is Kirchhoff's current law. I consider I1 is coming to this point, then it is divided into two parts. One part is there, so what will be the value of the other part? This part minus this part, that is 2I1 minus I. Now check whether at the bottom point this is satisfying the Kirchhoff's law or not. Just add these two. What is coming? I minus, and what is coming through this? 2I1 minus I. Add these two. What you will get? I1. So current distribution should be such that Kirchhoff current law is not violated. Clear? Now I will write Kirchhoff voltage law for this loop. This one. I consider this one as the loop 1. This is loop 1, this is suppose loop 2. I will write for loop 2 first. Okay, see. I will first write down the names A, B, C, D. So first loop will be this one, A to C, then to D, then back to A, in this manner. A to C, then C to D, then D to you will encounter low potential later and high potential earlier. So low minus high will be negative. So you write this one as minus 2 into I minus I1. Fine. Next, C to D. Current is coming from D to C. That means high potential is this one, low potential is this one. You are going in opposite. So you will encounter high potential later. So difference is high minus low, that is positive. So it will be plus 1 into 2I1 minus I. 1 into 2I1 minus I. Then D to A. Plus or minus? Plus 1 into I1. 1 into I1 plus. This entire sum will be 0. Check once again the Kirchhoff voltage law, whether it is correct or not. You are going from A to C first, but current is from A to C, means high potential to low. So you are finally reaching C. So final minus initial to you is low minus high. Low minus high is negative. So that's why minus 2 into I minus I1. Then from C to D, current is going from D to C. You are going in the opposite. That means high potential minus low potential you will calculate. So that's why it is positive. Similarly from D to A, high potential minus low potential you will calculate. So that is also positive. Then simplify and find the relation between I1 and I. So it will be minus 2I plus 2I1 plus 2I1 minus I plus I1 equal to 0. Then 2I1 plus I1, that is 3I1. একটা কোথাও মিস করেছি বোধহয়, দাঁড়ান তো। 2I প্লাস 2I1 প্লাস 2I1, হ্যাঁ, প্লাস 2I1 মাইনাস I প্লাস I1, হ্যাঁ। Then it will be two I1 plus 2I1 plus I1, that is 5I1 equal to 3I. 5I1 equal to 3I. Okay. So what is I1? 3I by 5. So first complete this calculation. I will erase this part for the next calculation. So this type of derivation is not at all required, but for application of the, how to learn the application of the Kirchhoff's law, for that I use this problem such that you can apply the Kirchhoff's law to various loops. It is 2 into I minus, then plus 2I1, then 1 into 2I1. This is 2I, this is 2I1. How can you cancel? Okay. Right? So I1 will be equal to 3I by 5. Now I want to write the Kirchhoff voltage law for that loop 1. This one. See, I will erase this portion. See, write voltage law for this. Suppose the points are taken A, E, F, B, C, means this one. I write here A, E, F, B, C, A. This is the loop complete. That. See, between AE there is no resistance, no battery. So nothing we have to write. Then from E to F, you are going in anti-clock. Means you are going from E to F. So which terminal of the battery you will encounter first? High potential terminal, then the low potential terminal. So what is the drop? Negative. That is minus V. That is final minus initial. So that is minus V. Then here there is no resistance. Now when you are going from B to C, you will get resistance. So high to low current is flowing. You are going from low to high. So the drop will become positive. So plus 1 into I1. Okay, 1 into I1, because current is going like this. You are in the opposite direction. So this is high potential, this is low, and you are going from low to high. So final value to you is high, initial value is low. So high minus low will be high, means positive. This one. Next, you are going from C to A. Same thing. Current high potential is at A. Current is going from high potential to low potential at C, and you are going in opposite direction. So it is also plus 2 into I minus I1, and according to Kirchhoff's law this is 0. Okay. So from this can I write that V equal to I1 plus 2I minus 2I1. Take this V on that side. So V will be equal to I1 plus 2I minus 2I1. Then V can be written as 2I minus I1, and substitute the value of I now. What is value of I? You have I1. Substitute the value of I1 here in the last equation. It is 3I by 5. Substitute that and tell me what is coming. The equivalent of 7 by 5. Kero. এটাই তাহলে ইকুইভ্যালেন্ট রেজিস্ট্যান্স। কেন এটা ভি, আর এখান থেকে কারেন্ট বেরিয়েছে কত, সার্কিট থেকে আই। তাহলে মাঝখানে কী ঝামেলা হচ্ছে আমার জানার দরকার নেই। ভি বাই আই করা মানে এই পুরোটা। এই জন্য কারশফ লটা এত কাজে। এসছে what? Resistance is 7 by 5 ohm. That is the equivalent resistance. Just substitute the value of I1. I1 will be 3 by 5I. Then if you calculate, you will get this value. V will be equal to 7 by 5I. V will be 7 by 5I. Then what is the equivalent resistance? This part. Now you can say how it is the equivalent resistance you are claiming. The coefficient of I is the equivalent resistance. Why? Because see, in this entire circuit, I can't find anything to be parallel, anything to be series. I consider this battery. Now battery voltage is V. How much current it sends to the circuit? I. So if I do V by I will get the equivalent resistance. Means whatever be the problem between these 2 points, that I can completely eliminate. V by I means the total resistance between across the 2 terminals of the battery, and that is the equivalent resistance. So whatever be series, whatever be parallel, that I can completely ignore. Without any knowledge of series or parallel or anything, what is happen inside the complicated branch, I can completely ignore that to find the equivalent resistance if we can use Kirchhoff's law. So that is the main power of Kirchhoff's law. If you try to find completely series and parallel, there is nothing series in series, nothing in parallel. So don't think that in a particular circuit you will always get something in series, something in parallel. It may not be happening. If it happens, then you are quite lucky. But if you are not so lucky, then it may not happen. You can apply Kirchhoff's law to directly find it. Okay. So what we actually have to learn from this portion, that how to write the Kirchhoff's law for a particular case. This entire type of problem will not come in the NEET, but some small portions will come from which you have to calculate the difference of potential between 2 points by applying Kirchhoff's law. That is in some of the mock questions also. So you have to learn how to write Kirchhoff's voltage law, because current law writing is very easy, but voltage law writing students do mistakes because there are these directions. High potential, low potential, drop is positive, negative, so many problems are there. So you have to solve certain problems over that, such that you have a good command over writing the Kirchhoff's voltage law properly. Otherwise in the examination it is very difficult to write. If in the pressurized condition if you do mistake, then you cannot find the answers of the simple problem also, because the problem that is in your NEET's paper, one of the mock paper, Kirchhoff's law using find the voltage. If you miss the direction, you cannot find the voltage only. It is a one-liner problem, but you have to write the Kirchhoff's voltage law properly for solving those problems. Okay, so if you have any book, any book based on NEET or any textbook of class 12, you will find certain numerical problems given on Kirchhoff's law. Though it's a detailed problem, but still try to solve 2 to 3 problems such that you can write Kirchhoff's law properly. Then once you have a good command over writing the Kirchhoff's law, then don't solve those type of problem, because those type of elaborated problem will never come in the exam. But initially, since you want to learn Kirchhoff's law, try 1 or 2 those type of problem which was basically coming in board exam. Board exam problems you can solve properly, just 2 to 3 problems. Then you can understand how the voltage law is taken and all this, and then go for the NEET previous question, peer questions. Clear?